Okay, on Monday, we started an experiment. Okay, we're on page 109. Okay, we said, what do we want to find out during our investigation? What do we want to find out during our experiment?
How can water change?
You may go move your clip. I point it and ask Grant.
How can water change?
How can water change if what?
If you put it in hot
or cold. Yes. Okay, so how do you compare how heating and cooling will change water? So what do you think will happen? So we got 3 cups, and we put a 1/4 cup of water in each of the 3 cups, and I put one in the window, I put one in the closet, and we put one in the freezer. So what did you write? What do you think will happen? What do you think will happen? Xavier, what did you write?
It's hot, it goes away. It's cold, it freezes. And if it's normal, it stays the same.
Okay, so he thought if it was hot, it would go away. If it was cold, it would freeze. And if it was just in a place without hot or cold, it would stay the same. Now, he says if it's hot, it'll go away. It doesn't really go away. What happens to it, Xavier? It evaporates, right. We've learned that several times. It evaporates and turns into water vapor. But we don't see it anymore, right? Because we can't see water vapor. And the water vapor floats away. Okay, so he thinks, and I think that's probably what most of y'all probably wrote, something like that. Okay, why do you measure the water at the beginning of the activity? And why do you measure it again at the activity? Why do you got to measure it before we start and after we start? Heather?
Because if it goes away, then we don't know how it was last time.
Right, we have to know what it is before so we know if it's changed since last time. And hopefully you guys put marks on them. Did you put marks on them so we knew where the water was? Okay, so turn it to 110. Turn it to 110. And I'm going to go get our waters.
I don't think
What we started with. How much water did we put in each cup, Zeta? Right. 1/4 a cup. We call that 1/4 cup. So this is how you write it. So go ahead and write that on the top because that's how much we started with.
What is this?
So 1/4. 1/4. 1/4. They're all the same. Okay, so the one that was in the windowsill is right here. And it did go away a little bit. Now it's about 1/8 of a cup. 1/8. That means it's smaller. That's half of what was in there. So half of it went away. Okay. Now let's see the cool place. This was just hanging out in the closet where they didn't get any hot.
Same.
It's just a little bit less than, a 4, so a little
It must have been.
less than a 4.
It must have been.
Little less than 1/4 a cup. You need to be writing this. Here's this one. Can I measure this one?
No, you can look
Look,
at it.
I can look at it, but I can't pour out the water. Why? What happened to it?
It's frozen.
It's frozen. It actually looks like it went a little over 1/4 of a cup, but it's pretty much right at 1/4 cup. So 1/4 cup is what's still in there. It looks a little bit more, but you know what happens when the water freezes? It kind of expands a little bit. But it's pretty much right still at the dot.
Never waste water.
So let's look at our results. In the warm place, it went from a quarter cup and then half of it went away and it became an eighth of a cup. So it got smaller. An eighth of a cup is smaller than a quarter cup. We haven't learned fractions yet, but that's coming after money. Okay, a quarter cup. Well, now it went a little less than a quarter cup. Not much, but it went a little bit smaller when it was in the closet. And then it pretty much stayed the same, but it froze in the freezer, but it didn't go away. So we just compared our results with what we did. Now, think about your prediction, what you thought would happen. Xavier said he thought that the one in the warm place would go away, the one in the cool place would stay the same, and the one in the frozen would be frozen. So it was pretty much exactly what he said, except the one in the cool place did go away a little bit. So what do you think happened there? What do you think happened there? Why did a little bit of it go away? Chase?
Because it just stayed, the same.
It didn't stay the same. It went down a little bit. The one in the closet didn't stay the same. What do you think, Cooper? Maybe. And remember, heat, it doesn't have to be the sun. Just any heat can cause it to evaporate. Any heat. What happened this week? It got cold outside, right? So what did Miss Doty turn on in our classroom?
Heater.
The heater. Not the air conditioner. Now, the heater can't get directly into the closet, but it heated up this whole room. So it probably heated up what was in the closet and caused a little bit of evaporation. Now, I'm a little surprised that the one in the window evaporated as much as it did, right? Because there was no sun. Do you think almost the water would have been all the way gone if there was sun?
Yeah.
I think so, too. I think the water would have been almost all the way gone, but it still evaporated from the light, I guess, maybe?
A little.
And the heater in the classroom?
Maybe.
So, how does heating and cooling affect water? Okay? How does heating and cooling? So, heating, what does it do? Heating water makes it evaporate. That's right. It goes from, you can put makes it evaporate, or you can say makes it go from liquid to what?
Solid.
No.
Yes.
Gas. It went to gas. Water vapor is a gas. When we heat, it goes from liquid to gas. So we don't see the gas. So it looks like the water went away. It made it less. So you can either say heating water makes it evaporate, or heating water makes it go from liquid to gas. Okay? Freezing water was what? Freezing water makes it
Cold.
go from liquid, how we started, to,
Solid.
yes, solid. So heating water makes it go from liquid to gas, and freezing water changes it and makes it go from liquid to solid, which we already learned in science. We just haven't done it. So now we've actually done it and saw it with our own eyes. We actually saw the water go away when it was heated. There was not that much water left. We couldn't see the water vapor, but we saw that the water went away. And how did we know? We measured it in the beginning and we measured it at the end to get an answer. Water changed. So I want you to ask another question. What other question could you ask about the ways water can change? So what question, after we did this experiment, do you have about water changing? It has to be a question. So think of a question. Remember, questions have question marks. What is a question you have? No, write it down. Write down a question you may have about the way water can change. What's another question you have about water changing?